Good afternoon. This is Professor David J. De Los Reyes. I got a new topic this afternoon. It will be still a differential equation, first order, variable separable, number 9. Okay, let's proceed, guys. This is a variation of a problem under variable separable. My lesson for this afternoon will be a new lesson. This is DE10, Differential Equation, lesson number 10 on my channel. Under the course Differential Equation, first order, variable separable. This will now be example number 9. I saturate you with examples on variable separable. So when we go to the application problems on variable separable, real problems, okay, you will not be hard up. Okay, let's proceed. The given problem is this one. We are given the differential equation, quantity xy plus x plus quantity dx equal to quantity x square y square plus x square plus y square plus 1 plus quantity dy. The problem is asking for the relation of y as a function of x. There are no given initial conditions. So supposed to be the problem is asking for the general solution. Okay? Okay, let's bring out the solution. I will rewrite the given differential equation. The given equation is a differential equation. Why? It contains differential. It contains differential y and contains differential x. And the definition of a differential equation is that if an equation contains differential, okay, it is a differential equation. If it contains a derivative, it should still be a differential equation. Differential is dx and dy, and if there is a dy over dx, we term that as derivative. These are differentials. Okay. And from the definition of differential equation, it satisfies that the given equation got differential. So supposed to be what is given is actually a differential equation. Okay, and the problem is asking for y as a function of x. And since there is no given initial condition, supposed to be what is being asked is the general solution. Okay, let's proceed. I will rewrite the given differential equation. xy plus x close quantity dx equal to x square plus y square plus x plus y square plus 1 close quantity dy. By using algebraic manipulation, okay, we could do this. On the left hand side, there is a common factor x over here. So I factor out x. So what will remain will be a product of y plus 1. If we try to take the product of this, it is this, the expansion is this one. So actually this one can be written as x times the quantity y plus 1 plus quantity dx equal to, on the right hand side, for the first two terms, there is a common factor x squared. So we factor out x squared. Okay? Times quantity y squared plus 1, and for the last two terms, it is this. Right? Okay? Close quantity dy. If you try to notice it, on the right hand side, there is a common factor y squared plus 1. Right? So we factor out y squared plus 1. Okay, we got an x square over here, so this is x square. What remains on this will be plus 1 plus quantity dy. Okay, we just factor it out. Common factor is y squared plus 1, it is this. What remains as a multiplier will be x squared plus 1. This is x squared plus 1 times dy. Then, to separate the variables now, we will still do some algebraic manipulation. We will multiply all the terms by the quantity 1 over y plus 1 over x squared plus 1. Okay? So, for the left-hand side, 1 over this quantity here times the left-hand side, this y plus 1 cancels. So what will remain on the left will be x dx all over x squared plus 1. So this is x dx over x squared plus 1. On the right-hand side, the operation here, guys, is multiplication. So actually, we could cancel out terms, okay? This is y squared plus 1. This is this is y squared plus 1. This is x squared plus 1. X squared plus 1 cancel with this one. So what will remain on the right will be y squared plus 1, this one, times dy. On the bottom portion, okay, it is y plus 1. You got it? So after multiplying all the terms by this 1 over y plus 1 times the quantity x squared plus 1, actually we already have separated the variables. That's why the topic is variable separable. Okay? This is now pure function of x. This is now pure function of y. So actually, we already have separated the variables. So the main topic, variable separable, it is this. Then to bring out the solution, try to integrate both sides. Right? Therefore, the integral of x dx over x squared plus 1 equal to the integral of y squared plus 1 over y plus 1 closed quantity dy. We are now integrating. Okay? So, the main problem is to bring out your knowledge of integration. For the left-hand side, it seems this is under the power formula. It is x dx over x squared plus 1. If we think that this is under natural logarithm, the value of u is actually the 1 at the bottom. It should be x squared plus 1. du will be 2x dx. It is not exact. We got an x dx, but we lack the value 2. So we will place 2 over here, then we'll place 1/2 outside. Okay, for it to fall under natural logarithm. Okay? So, as a continuation, this is actually 1/2, the integral of 2x dx over x squared plus 1. Actually, we inserted this one, and we put 1/2 outside. Equal to, the right-hand side is a quadratic equation over a linear equation. Okay? First rule under integral, if the power of the numerator is greater than the power of the denominator, before the integration, try to divide first. And I place it here. Y squared plus 1 over y plus 1. If you try to divide this by using long division, what will come out will be y minus 1 plus 2 over y plus 1 using long division. And as a proof that the equivalent of this is this one, it's this. Y squared plus 1 divided by y plus 1, the first dividend is actually y. Okay? Y times y will be y squared. Y times 1 will be plus y. On the pure constant, it will be 0. Then try to subtract. The operation is subtraction, right? So y squared minus y squared will be 0. 1 minus 0 will still be plus 1. Okay? The operation is subtraction, so this becomes minus 1. This is now, we bring down this one, so this is 1 minus y. And the next dividend will be minus 1. Minus 1 times y will be minus y. Right? A minus 1 times a plus 1 will be minus 1. Then perform the operation subtraction. Okay? Plus 1 minus minus 1, so that will be plus 1 plus 1, that is plus 2. Okay? This is minus y. Minus y, this will become plus y. So a minus y plus y, this will become 0. So after the long division, the remainder is actually 2. So the remainder is actually plus 2 over y plus 1. So I place it here. The long division of y squared plus 1 over y plus 1, the equivalent is actually y minus 1 plus 2 all over y plus 1. It is this. We now already have integrated the left-hand side. It is under the natural logarithm. So we will place the equivalent of the terms on the right-hand side after the long division. So this should be y minus 1 plus 2 over y plus 1 closed quantity dy. Then try to expand. Left-hand side, this is now integrable. This is 1/2 the natural logarithm of x squared plus 1 equal to y dy will be the integral of y dy, minus 1 times dy will be minus the integral of dy. 2 over y plus 1 times dy will be 2. I bring out 2, it's a constant. The integral of dy over y plus 1. This falls under the power formula. This is an exact differential. And this falls under the natural logarithm of u. Okay? And this should be, no. It falls under a du over u. And the answer should be natural logarithm of u. Where the value of u is actually y plus 1, du is equal to dy. dy, this is exact. Okay? So, I will try to bring out the final answer. Final answer, this should be 1/2 the natural logarithm of x squared plus 1. Okay? The first one on the right, it falls under the power formula. Y squared over 2. Second one, exact differential, this should be minus y. Plus 2, the natural logarithm of y plus 1 plus k1. Actually, we could say that that will now be the final answer, or we could simplify something like this. This is 1/2 the natural logarithm of x squared plus 1. This one, we put it on the left, so this will be minus 2 the natural logarithm of y plus 1. Simplification of the right hand side, y squared, y times 2 will be minus 2y over 2 plus k1. So actually this is now the general solution, and that is our answer. That's it, guys. It's a simple matter of solution. If you know your integration, you know your algebraic manipulation, you know how to separate the variables, you know how to integrate, you can bring out your answer. So the main topic for this afternoon, differential equation, first order, variable separable, example number 9. Good afternoon, Los Angeles.